guys, welcome to another machine learning tutorial. Today we're going to show you how you can use TensorFlow GPU on your local machine and train object detection models with it. So before we get started, I want to give a huge shout out to Edge Electronics. We are going to use a lot of their resources from their GitHub page. The link will be given in the description below. So let's get started. We will be using Anaconda distribution for this project. It's a very popular machine learning platform. You can download it from free. Click get started. See all Anaconda products, individual edition, download. To save some time, I have already downloaded my Anaconda so that we can move on. So first, create a folder named TensorFlow 1 on your C drive, directly on your C drive. We are going to download the models, TensorFlow models from their GitHub page. The link will be in the description. So click on download now. Go on download and then download zip. As you can see, the download has been started, but I have already downloaded this, so we'll skip ahead. Next, we are going to download the model for training the faster RCNN Inception V2 model. So we're going to click there, and as I have already downloaded this, so we're going to click cancel. So here it is. Now we're going to copy and paste these files. After creating this TensorFlow 1 folder, we're going to get back this models master that we have downloaded, copy this and paste it inside TensorFlow 1. For pasting it, we're going to rename it to just models. Then let's go to the object detection folder. Here we're going to paste our model that we have downloaded from the TensorFlow model zoo. The link is in the description. So here's the model. We're going to copy this file and paste it here. There we go. Then we are going to download this entire repository from Edge Electronics GitHub page. I've downloaded it already, so here is that. So we're going to copy all of this and paste it here, and click replace the file in destination. Here we go. As the repository already had the files after the model has been trained, so we are going to delete some of the files that we are going to generate after training our model. So let's delete these files from the training folder. Then from inference graph, delete the placeholder, and from the images folder, delete these two files. So as you can see, in the test and train folder we already have some images. That's because we are going to use this image from Edge Electronics. If you're going to test your own dataset, then this folder should be empty as well, so you can delete all of these images and follow along. So for our next part, we're going to create an Anaconda virtual environment. So for that, type Anaconda prompt and select run as administrator. So here, type in these commands: conda create -n TensorFlow 1 Python is equal to 3.7. There has been an error. Should be in the double quotation. 3.7. Enter. Select yes. And now it's done. So now we're going to activate the environment by typing in conda activate. TensorFlow 1. So now we're in. You can see that the base has been transformed into TensorFlow 1, which means we're inside the TensorFlow 1 environment. Now we are going to install our TensorFlow GPU. So type in conda install TensorFlow -GPU. We are going to use TensorFlow GPU 1.14 since this is a more stable version. Also, the community support is there as well. So press enter. So again, why? So you guys may already know that TensorFlow GPU requires some additional software for that GPU support. Using Conda, it automatically installs those softwares based on the TensorFlow version, so you don't need to worry about that. So as you can see, it's done. So next we are going to install some of the other additional stuff. So typing in these commands: conda install -c anaconda protobuf. So now pip install below. Again pip install lxml. Pip install jupyter, jupyter. Pip install matplotlib. Then pip install pandas. Lastly, pip install OpenCV Python. Then we're going to set some path variables. So we are going to go to the models folder. So here, and copy this. Now type in set Python path is equal to the address, and semicolon, models research, again models research slim, press enter. Now we're going to update the path variable. Path is equal to %path semicolon Python path, and it's done. Now we're going to change our directory to the models research. So cd models research. Here we're going to copy a protobus command from the GitHub repository of Edge Electronics. It's a long command, so just copy this bit and just paste it here. So at this point you're going to prepare your data. Now we're going to go to the object detection folder. So research object detection, and copy this address, paste it here, and now we're going to run the following commands: python csv dot py. Then we're going to generate the TF records. Again, we're going to copy these commands from their GitHub repository. So here it is. And then this one. So what this did is it created this test.record and train.record. Now we're going to go to the object detection data folder and open this bbtxt file. still loading. Okay, so create a file, a text file, and then paste this. Copy this from here and then paste it, and then save as. Save it in the training folder in the C drive. And name it as label. Done. Then go to the samples folder, configs, and select the faster RCNN Inception V2 pets. Copy it and paste it in the training folder. Now we are going to edit it. So first, the num classes will be 6 since we are identifying 6 individual objects. Then we're going to follow the instructions. So fine tune checkpoint. We're going to copy this code from here and go to the fine tune checkpoint. So here it is, fine tune checkpoint. Path to be configured. Paste this, and notice these are all forward slashes, not the backslashes. So please keep this in mind while copy pasting your address. Now we're going to change this input path. In the train input reader section, here it is. Train.record, and label map will be the location of our label map inside the training. Then the eval config, number of examples. So here we have a total of 67 test objects. So number of examples will be 67. And then the eval input reader. Again, we're going to copy this from here. And we're done. Press Ctrl F and saved. Now we're all done, so we are going to start training our model. So we're going to copy this training command from here and paste it over here. Okay, so here the train.py is not found. That's because the newer model has changed the train.py location a little bit. So this file is inside the legacy folder, which is over here. So here is the file we are looking for. Copy it and paste it in the object detection. Now if we run this code again, there we go. So the original training will start in a bit. Just preparing. And now the training has started. As you can see, there is a loss count shown in here. So we're going to stop when the loss is significantly below 0.0 something. It will take some time, so see you after that. Also you can view this results in a tensor board, and you can see the graph. Just open another anaconda prompt, run as administrator, and activate the render environment. So anaconda activate TensorFlow 1, and then go to the object detection folder, so cd, and then just copy this address from here, paste it, and then now write tensor board dash dash log here, go to training, press enter. Now go to this website. It's gonna be hosted in your local machine. As you can see, the port 6006 sometimes don't work as expected, so we're going to use the following command instead. So we're just going to add this part at the end. So let's see. Still here, and now it's working. So this is a loss graph, so still pretty high. So when the loss graph falls significantly below 0, we're going to stop our training. So till then, let it train. As you can see, the loss is way below. We are going to stop this by pressing Ctrl C. And it's done. Now we're going to go to the training folder and keep note of the highest checkpoint, which in this case is 3865. Now we're going to generate our frozen inference graphs. And now we're going to copy this path from here to export the inference graph. So copy it and replace this x variables with the maximum number here, so which is 3865. So 3865 and press enter. Now that it's all done, let's test our model. So type IDLE, click on file, open object detection webcam. Before you run this thing, make sure to edit this part, num classes, and then run. As you can see, that it takes up perfectly. Ctrl Q to exit. Okay, so press Q to exit, sorry. Now that's done. That's all. Okay, so that's it for today. If you guys have any confusion or any question, you can leave it in the comments below. And we'll see you in the next tutorial.